Hi folks, Buckley here. This talk is about concept generation and selection. It's meant as a review of some of the material that we went over in Engineering 101. Also, if you haven't taken 101, this is a good guide. So we here at Delaware have a 4-phase design process. Phase 1, define the problem. That's what you guys have been working on. Phase 2 is concept generation and selection. We are now solidly in phase 2 on our project, so I'd like to go over concept generation and selection sort of at a high level here. Let's talk about those two things separately. So concept generation. So our expectations around concept generation are that you generate at least 3 unique and valid concepts. Unique means each of the concepts is different from the other one. They're not derivatives of the same concept. And valid means that each concept is consistent with your scope, and it also has a chance of meeting your constraints, so the constraints that are posed on the problem. So that's what we mean by unique and valid. And it's important that our concepts fit both of these categories, because there is a chance that whatever concept you choose, whatever concept is selected, may not work out. When you get into it in phase 3, the concept may not be working out. You have to abandon that concept and go back to phase 2 and pick another concept from your set of concepts. And if that concept is the same as your other concepts, meaning it's not unique, you're going to be in trouble, because that other one, your backup, is also going to fail. And if it's not valid, meaning it can't meet the constraints, it's going to fail. So you need 3 unique and valid concepts, really, so that you have a viable backup for the concept that you choose. Okay, so equal effort on every concept. Make sure that you've got 3 unique and valid concepts. You're going to generate 2 things for each of those concepts. One is a high quality sketch. This should be an engineering sketch that shows functionality and form of the concept. Okay, so this is an engineering sketch. It should be high enough quality. You should generate what we call a patent quality sketch, right? So nice line weight, nice and neat. Okay, make sure that you scan it in. The other thing is that write a 1-paragraph description of each concept. So to go along with the image, have a description that kind of at a high level explains that concept. So that's what we're expecting. So we've been working on our project, which is the Modern Art Construction Toy Set. This is the example that we've been using in class. The scope for this project is to develop a modern art themed toy that promotes constructive play, et cetera, et cetera. The concepts that we've generated for this modern art construction toy set need to be consistent with that theme, right, or that scope. So if one of my concepts, for example, is like a plumbing construction set, right, so tubes together and we put water through it and it's got no connection with modern art, that's not a valid concept, right? So make sure that all of the concepts that you're putting forth are consistent with the scope of your project, right? So we've got 3 concepts. I'm just going to show you some images of those 3 concepts. I don't have sketches for you, but concept number 1 we're calling Serra blocks. So this is a famous artist called Richard Serra. He's got these very large metal structures. This is almost 2 stories tall, that perfectly balanced. So we're going to create some blocks that are sort of like that, 3D in form, rather large Serra blocks. The second is a mobile, which is the origin of this art form is a man named Alexander Calder. These are large sculptures. This is one that is actually in Philadelphia. Do-it-yourself sort of Alexander Calder themed mobiles. The third is a woven sculpture by an artist named Ruth Asawa. So this would be a way that you could link together different pieces to create a woven structure. Okay, so those are our 3 concepts. We're going to call them again Serra blocks, mobile constructs, and woven sculpture. Now, if those were our concepts, and obviously we showed photos there just to kind of tie in the art form, but we would want to have had sketches, patent quality sketches there. That's what we are expecting from you, okay? As well as a 1-paragraph description to go with it. So I'd like to, at this point, move on from concept generation to concept selection. How are we going to pick which of these concepts to move forward with? There are better and worse ways to do concept selection. Once you get to senior design, so in what 2 to 3 years, you will be able to use pretty much any method that you want in order to do concept selection. But here in this class, we're going to insist that you use a method called a decision matrix. But it's valid to consult an expert designer to make prototypes of each design and test it. That can be kind of an expensive way to do it, or to use a decision matrix. So all three of these here are valid options. These are sort of the worst option equivalents to this, right? So you want to be on this side of the chart. We are gonna use a decision matrix, but again, in senior design or in your practice as an engineer, just know that there are other ways to do it. You're not always using a decision matrix, but this is the way we're going to force you to do it in this class because it's very systematic. All right, a decision matrix it's a way to systematize concept selection. So it starts with prioritized stakeholder wants or metrics, and it's very important to specify which of these you're working with. Are you working with wants or are you working with metrics? You're not working with constraints, right? So all of your concepts by default should satisfy your constraints. Let me repeat that. All of your concepts by default, because they're unique and viable, should satisfy your constraints. So when you're comparing them, the only things that you have left to compare on are really your wants or the metrics that are associated with those wants. You're going to rank your concepts against each other using preliminary data and or intuition. Okay, so maybe you have a little early data on how these concepts were performed, or most likely in your case, you're going to have intuition. Okay, that could be your intuition. That could also be your HDFS consultant's intuition. There are different algorithms that you can use for scoring concepts. We're going to introduce two of the more popular algorithms. It's called a Pew matrix and also a weighted matrix. It is your call which of these you want to use. Okay, so let's dig into that. Generally, when you're using these algorithms, the concept with the highest score, quote unquote, wins, and that's the concept that you're going to advance. Okay, so a Pew matrix is an unweighted system. It's an unweighted decision matrix system. It assumes all wants or metrics are of equal importance, and it works really well to thin down long lists of concepts, right? So if you've got a long list, you need to make a first pass through and thin down the list. A Pew matrix is a good way to go. Honestly, for this project, it's also a good way to make that final choice, okay? The way that the Pew matrix algorithm works is that you first select one of your three concepts as a reference. Okay, so your reference is going to score basically neutral on all of the wants or metrics. And then you're going to rank concepts for each want or metric as better than the reference gets a score of +1, same as the reference gets a score of 0, and worse than the reference gets a score of -1. And then you're going to total them up. So let's see how this works with our project, which is the Modern Art Construction Toy Set. Okay, so first I'm gonna select one of these concepts to be my reference. I'm gonna pick Sarah Blocks. It could be any of these three. It doesn't matter. Okay, I could pick Mobile Constructs or the Woven Sculpture, but I'm picking Sarah Blocks. So now I'm comparing everything to the Sarah Blocks, right? So let me start with modern art, which is most going to be consistent with modern art relative to Sarah Blocks. Okay, so I basically say that the mobile here is probably a little bit easier to see as a modern art form than the Sarah Blocks. Not everybody knows about Richard Serra and the balancing blocks, but most people have seen a mobile. More people are familiar with Alexander Kildare. Fewer people are familiar with Ruth Asawa and her woven sculptures. So this is how I ranked it. +1 for mobile constructs, woven sculptures, a -1. Engaging, I felt like the Sarah Blocks are blocks, right? So, there's only so much you can do with balancing blocks. Mobile constructs, there's a lot going on there with torque. There's kind of like a static equilibrium that can be happening there. And the same thing could be happening with the woven sculpture, right? Durable, okay, again, everything referenced to the Sarah Blocks. Sarah Blocks are going to be indestructible. The mobile constructs and the woven sculpture I felt like were lesser in terms of durability. Educational, mobile constructs came out on top. I was unsure, woven sculpture versus Sarah Blocks. I went with those two being neutral. And then low cost. The woven sculpture would be much cheaper than the mobile constructs. Mobile constructs would also be more expensive than Sarah Blocks. So that's how I ranked it. Now, I'm kind of rattling off, again, my intuition. I would want to take some notes perhaps on and if I have preliminary data to back this up, to make sure that I document it, okay? But let's say this is my scoring, okay? So Sarah Blocks obviously is going to total 0 if I add these up. Mobile Constructs, I have +1, +1, -1, so I'm still at +1. +1 is +2, -1 is +1. Okay, Woven Sculpture, plus, minus, plus, 0, minus, or minus, plus, minus, 0, plus is 0. So I get 0, +1, 0. So my rank is 1, 2, 2. Okay, top performer is Mobile Constructs, followed by a tie for second place, Woven Sculpture and Sarah Blocks. Okay, so that's how that worked out. All right. Now, know that, so that was the Pew matrix. Now we're going to talk about a weighted matrix. So weighted matrix incorporates priorities of wants and metrics. It works really well as a tiebreaker between designs that are fairly close to each other, right? So the way that a weighted matrix works is that you prioritize your wants and metrics first and assign weights to them, right? So if it's really, really important that this looks like modern art and it's less important that it's low cost, you would assign a higher weight to the modern art metric than the cost metric. You're going to score components for each one or metric, with the higher score being better, and then you're going to multiply in sum total. So let's see how this works. First thing I'm going to do is I'm going to set a weight for each of these wants, right? So for engaging, it's 35%, modern art 25, educational 25, durable 15, low cost 5. So these weights, this is my most important. So the way that you can look at this is engaging right now is 7 times as important as low cost in terms of how I want my outcome to come out. Okay, so on these you would just score right across the bat, and you can also decide how much of a spectrum you want here. All right, so I've got a 10-point scoring. All right, you could do 100-point scoring. It doesn't matter. That's just going to cause those numbers, the total, to be a little different. Okay, so what I thought here was Mobile Constructs are obviously more engaging than Sarah Blocks and Woven Sculptures. Going through and kind of doing the same justification I did for the Pew matrix, I can work back. I can work through each of these weightings. Okay, so note that all of this is arbitrary. This is something you're deciding. This scale is something you're deciding. You're using your intuition or some preliminary evidence that you have gathered to do this ranking. Okay, then what you do is you multiply, right? So the score for Sarah Blocks is going to be 0.35 times 5 plus 0.25 times 2.5 plus 0.2 times 5 plus 0.15 times 10 plus 0.05 times 10. Okay, and then total all that up. That gives you 3.6. Same deal over here. 10 times 0.35 plus 10 times 0.25 plus 10 times 0.2 plus 5 times 0.15 plus 7.5 times 0.05 gives me 5.6, and then 4.1 for this one. Then you're looking at the numbers, right? Mobile Constructs comes out at 5.6. Next in line is Woven Sculpture, and then Sarah Block. So I've got 1, 2, 3. Okay, when you're talking about rankings here, whether it's the Pew matrix or the weighted matrix, it's really important to not talk about this score, but to talk about relative performance. So first, second, third place, not my score was 5.6, 4.1, and 3.6, right? These are arbitrary numbers that have come from some decisions that we've made about the weighting and also what this numerical scale is here. All right, so if I want to talk about the overall performance, I would say something like the Mobile is 55% better than the Sarah Blocks and 36% better than the Woven Sculpture, right? So this would be the difference between 5.6 and 3.6 and 5.6 and 4.1. So talking about it in terms of percentage, not in terms of absolute. When you're reporting on your concept selection, you want to specify a couple things. You want to talk about the type of decision matrix used, whether you ranked wants or metrics, relative, not absolute ranking. So that's back to that principle of, 55% better versus 31% better. You also want to give a big picture of why the chosen concept came out on top. And then if you're writing your report, and when you write your report, you're going to put your decision matrix in an appendix. That's not going to go in the main body of your text. So you want to make sure that you're referring to that appendix. Okay, so here's an example of the write-up that would go along with concept selection for our project. This is, we're expecting 1 to 2 paragraphs that explain the process. So a weighted matrix algorithm was used to select the most viable concept. Following this algorithm, our 3 concepts were ranked against the top 5 highest priority stakeholder ones. So it's telling me a couple things, right? I'm using a weighted matrix. I'm ranking according to wants, and I had my top 5 wants only. So maybe I had a total of 15 wants, but I'm only using my top 5. Okay, and then here's the results. The top ranked concept was Mobile Constructs, which scored 36% higher than Woven Sculpture and 55% higher than Sarah Blocks. This was largely due to Mobile Constructs scoring highest amongst all 3 concepts on the top 3 wants, specifically engaging, modern art, and educational. So I talked a little bit about why Mobile Constructs was coming out on top, right? I just didn't leave it hanging. This is important because you should always know why something is happening. You want to explain your results, okay? All right, so that's what I have for you guys in terms of concept generation and selection. Thanks for listening, and good luck on milestone number 6.